Hello, Miss. I'm Oscar Wright, student number 7273, and this is my graded assessment for data analytics in May 2020. Okay, so first of all, question 1. What is the format of the variables, qualitative or quantitative? So here we have our 4 variables. We have gender, nationality, age, and total spending. We don't include guests for one of these variables as it's not a variable, it is stated. Each guest has their numbers 1, 2, 3, 4, 5, all consequentially down to number 30. So therefore we have 1, 2, 3, 4 as our variables. Right, so qualitative variables. Qualitative variables are non-numeric, and so therefore our 2 qualitative variables are gender and nationality. Age and total spending, however, are both numerical values, so we can say that those are quantitative variables. Question number 2, what type are the variables, categorical, continuous, and discrete? Right, so for both continuous and discrete, those are numerical values, however categorical is non-numerical values. So here we have gender and nationality, those are 2 non-numerical variables, and so we can say that those are categorical. That makes sense as well, because if you try to place someone into their gender, they're going to be either a male or a female. Nowadays maybe you have other options, but in this example we have just male and female, and that's a category, so either one or the other. In the nationality, same thing, there are a few more options, a few more categories, but they're still categories. Then we have age would be our discrete variable, as we're talking about a whole number. The data doesn't differentiate between 67.5 years old or 67.2 years old, it's still 67, so because of that we have proper classifications, and it's not an infinite continuous scale, it's made up of whole numbers, so therefore we classify it as discrete data. Then the total spending, this is continuous as there's no limit and could increase every time a guest spends more. It's a continuous scale, and there are infinite values that the total spending could have, therefore we would say it's a continuous variable. Question number 3. Prepare the descriptive statistics for all the possible variables using the data analysis tool pack. Explain why you chose those specific variables and not others. Okay, so first of all, we're going to choose the age and the total spending as our 2 variables to produce the descriptive statistics for, as these are numerical values. As we can see here, the descriptive statistics are all numerical values. And so it would be impossible to produce those for the categorical variables like gender and nationality. In order to create our descriptive statistics using the data analysis toolpack, we're going to highlight the 2 columns that we want to select. We're going to include the labels as well. We're then going to click on the data tab here at the top, and we're going to click on data analysis. We're then going to click on descriptive statistics, as that's what we wanted. We click OK. Now we have to input our range. The range, as I said before, will be the 2 columns that we want to create the descriptive statistics for. It is grouped by columns, and because we included the labels in the first row, we're going to click this box that says labels in first row. We want to produce the graphs in this worksheet, so we're going to click output range, and we're going to select the cell, well, it would be here. Then we have not been asked to do the confidence level, but we can include it, so we can click this box here, and we obviously want our summary statistics. We would then click OK, and because I've already done it, I'm not going to bother, but you'd get these 2 boxes or two lists which have descriptive statistics for both the age and the total spending in euros. One thing to note, however, is the modes. The modes can be taken for the gender and nationality, as it's the most common value in the data set, and therefore we could take the mode. It just depends which of these is the most frequent or that has the highest occurrence. For the gender, there's actually 15 males and 15 females, therefore there's no modal gender, as it's completely even. If there was, say, 16 females and 14 males, then the modal gender would be females. However, it's 15 and 15, so there's no modal gender. Here we can see, however, that there's, in the nationalities, there's a lot more Spanish than there is any other nationality. In fact, there's 20 Spanish, which is the highest occurring nationality in this column. And we can therefore say that the modal nationality is Spain. So, whilst we can't produce the full descriptive statistics for those two variables, we can do the mode. Move on to question 4. Which are the central tendency first of all, we need to create the descriptive statistics of the total spending and answer the following questions. So again, same as we did before, we just select, or we're going to first of all click on the data tab, we're going to click on data analytics, descriptive statistics, and it's going to be the exact same as last time. The only difference is that we're going to, for our statistics, we're going to just select the data that we have here. And we can do our output the same as we did last time, but as we already have the table here produced, I'm not going to bother doing it again. So we have question number 4, which are the central tendency measures? So you can see here that the central tendency measures is the mean, the median, and the mode. And it's highlighted in blue, the central tendency measures, and the 3 that are there highlighted in a nice blue color. Question number 5, explain the central tendency measurements. Okay. So first of all, the mean. The mean is the average for our data set. It's calculated from dividing the sum of the data by the count of the data. And when I say count of data, I mean how many data points there are. So in this example, there's 30, as we can see here. And here the mean is €1,695.90. The median is the next central tendency measure is the very middle value of the range, i.e. the number that is right in the middle of the minimum and the maximum values of the total spending, that is 1,664. And then finally we have the mode. The mode is the most repeated or highest occurring value in the data set, indicating the value that has the highest frequency of observation. In this data set, however, we can see that we have no mode, and that's because no value is repeated. So each value appears once and once only. So unfortunately there's no mode for this data set. Question number 6. Which are the variability or dispersion measurements of the total? So we have standard error, standard deviation, sample variance, and range. These are our variability / dispersion measurements. Question 7. Give an explanation or definition about each of the variability measurements you provide. You identified, sorry. So first of all, the standard error. The standard error is the standard deviation of the sample mean in relation to the population mean. So here it's 50.23, which we can say is relatively dispersed from the population mean, but that's what we'd expect perhaps. The standard deviation is a measure of the average amount of dispersion or variation the members of the group, i.e. each piece of data, so the group is the whole data set, have from the mean of the data set. So again, from the mean here. This is all in the sample, we're not talking about the population here. So we can say that on average, as the standard deviation here, we can see is 275.11. We can say that on average, a data point varies from its mean by that value, 275.11. So some obviously are going to be further away from the mean, some are going to be closer than that to the mean, but just on average, it's going to be 275.11 away from the mean. The sample variance indicates the exact same thing, or very similar thing to what the standard deviation indicates. Again, it's an indication of the spread, or how spread out the values are from their mean. And is calculated by taking the standard deviation and squaring it or raising it to the power of 2. Here we can see the variance is 75686.714. Obviously the values are going to be bigger, which is as expected when you square the value. The range is the last variability / dispersion measurement, and it's the total spread of data, and it's calculated by subtracting the minimum or the lowest value from the maximum or the highest value in the data set. Therefore, another definition is the difference between the minimum and the maximum values. Here the range is 971, which appears typical given the value each data point represents. So that's the range. Then question 8. Which of the measurements of the shape or normality includes explanations? Okay, so for the shape or normality measurements, we have it in light blue. We can see here we have kurtosis and skewness. So first of all, kurtosis is an indication of the distribution of data and how flat or steep the graph or plotted data points would be. So when we know that when k equals 0, the graph would be taking normal distribution, but in this case it's negative. We have minus 0.85, which means that the graph is flatter than a normal distribution. If it was positive, it would be more steep, more of a point, as it would indicate a higher concentration of data points around the mean. However, in this one it's more flat, so we can say that there's less or a lower congregation of data points around the mean. It's more spread. Then the skewness is an indicator of the dispersion and its symmetry either side of the mean when observing the same graph. When the skewness is 0, we can say that the graph is symmetrical, so it's the same on one side of the mean than it is on the other side of the mean. However, in our situation we have a positive skewness, which means that the graph would have a tendency to the right, so above the average point or the mean, or the equilibrium also in the graph. And that means that there's a higher concentration of data points above or to the right of the mean. Question number 9. Calculate the confidence interval with 95% confidence level for the total spending and explain what it means. Okay. So the confidence level, or the confidence interval we can see here, at a 95% certainty is 102.73. I've just got that a little bit wrong, but I can change that afterwards to 102.73. But what this means is that the mean of the population is plus or minus this number, 102.72, from the sample mean, with a confidence level of 95%. So, in essence, there is a 95% chance that the population mean is between the lower confidence level, which is the sample mean minus 102.72, and the higher confidence level, which is sample mean plus 102.72 of the sample. So essentially, this is saying that we are, or it's the same as saying that with a confidence level of 95%, we can say that the population mean, or the actual mean of the population, is plus or minus 102.73 of the mean that we have for this sample, which is here. Okay, so now we're going to move to question 10 to 9. Okay. Question number 10. Prepare a frequency table, absolute frequency, relative frequency, cumulative frequency, relative cumulative frequency, and a histogram for the variable of the total spending in order to be able to answer the following questions. Okay. So, first of all, what we've done is we've copied and pasted our total spending column from the previous tab, as we're still going to be using the same data. And what we've done, first of all, is we've taken the minimum and the maximum values from this data set. All we did to do that was enter the formula for the minimum value, which is equals min, and then we just select the whole range. Again, with the maximum value, we just click the formula equals max, and select the whole range, and we come out with this maximum value. The reason we did this is to then be able to create the bin range. So we got an idea, at least of the range of values. We have around about 1,000 difference. So that makes more or less 10 categories of 100 range in between each class. And the bin range, or the bin, refers to the upper value of the class. So the first bin, as we can see, it relates to the column here, where it says 0 to 1,100. Again, 1,200 therefore would be 1,100 to 1,200, 1,300 from 1,200 to 1,300, and so on. Then what we need to do is we need to go onto our data tab. We need to click onto the data analysis at the top, and we click this time on histogram, as we wanted to create a histogram graph and the table, the frequency table. So we click OK. we select the input range, which is the same. Again, we're going to keep continuing to include the label. And we select our bin range, which is, again, the bins that we've just typed. Again, we're going to select the label as we did for the previous column as well when we selected the total spending. We then make sure we click the box because we did select the labels. We're going to click the output range. We want it to come out over here. So when we click that, we would of course click there. That's the cell we want it to output onto. And then obviously we want the histogram, so we're going to click the chart output down here as well. When we click OK, we should come up with a table, although for the purpose of this, I'm going to change the output to up here. And we'll see what we come up with. Okay, so we have our histogram, we have our table. So now what the next step that we would have needed to do, which I did before already, is to just replace these with the actual class that they refer to. And we would have done the same the whole way down. And then instead of more, we're going to replace that with 2200 plus, or you can keep it as more, it doesn't really matter. Just so that it's clear for you. And then we of course get the frequency. Again, this is the same as absolute frequency, just because the question asks for absolute frequency, I changed it to absolute here. But again, if you keep it as frequency, that's also fine. Then with the histogram we're just going to increase to the right size. And what we need to do is we need to click on we need to click on the bars, and then we go down, we click on Format Data Series. I don't know if you can see that. If you click on Format Data Series, and you have a tab here at the left-hand side, and you just need to reduce that gap width to 0%. And if you close that, you can see that the histogram will have the bars nice and close together, which indicates that there's continuity and it's a flow rather than a bar graph. And we can obviously separate out the categories a bit better, change the title, make that look pretty, as we've done just below. We're going to delete that now, and we're going to delete this as we already have the data. Let's just clear that up a little bit. Okay. So now the question also asked us for the relative frequency, the cumulative frequency, and the relative cumulative frequency. So the relative frequency is basically the percentage, or the percentage of the total count that each frequency has. So the first step we need to do is we need to take the sum of this column, which we've done here, and you can see here it says sum of the data. If we double click that, you can see exactly it's the sum of this column. And then for the relative frequency, therefore, we take the result in the corresponding column and we divide that by 30. So that's what we've done here. You can see that the formula is 0 divided by 30. And what we're going to do is we're going to put a little dollar sign in between the F and the 36, as that's going to lock our cell in place. And when we drag down, it's going to keep it the same cell for all of it. So if you click here, now I can see it's still, the absolute frequency is 4, but it's still dividing by the same total of 30. That's the relative frequency. Now for the cumulative frequency, essentially it's added up. So we have it's essentially the frequency plus the total so far. So we have the same as the absolute frequency for the first two columns because it's 0 and then 1. But then for the next column, essentially you can see that it's the newest frequency plus the frequency that we had up to this point. So when I click on the formula for this one, you can see it's the frequency for the bin range, or for the range, plus the previous result above it. And again, if we scroll down, we can keep going. It's the same thing, and it's all the frequencies accumulating together as we go down, or as we go through the data. Then the relative cumulative frequency, we have two ways of calculating this. However, the way that I chose to calculate was by taking the cumulative frequency and dividing it by 30, as that gives you the result. The same that we did for the relative frequency, but instead of using the absolute frequency in the total, we're using the cumulative frequency in the total. So if I click on the formula for this one, for example, you can see that it's this divided by this. Okay. As I mentioned the histogram already, so that should be question 10 done. We're just going to check. Yes, okay. So question number 11. How many people spent between 1900 and 2000 euros? So to find out the answer for this one, we need to have a look at the absolute frequency column, as that tells us how many people were in each range, just for that specific range. So we know that the range was 1900 to 2000, so we just look next to that, and the absolute frequency, 1. The count is 1, so we know that only one person spent between 1900 and 2000, as we put here for question 11. Question 12. In terms of percentages, how many people spent between 1900 and 2000? So it's the same question, but it's asking us for a percentage instead of a whole value. So basically we take this one person, and we divide it by the total, but that's exactly what we did in the relative frequency column. So we can say with good certainty that it's 3.33% that's spent between 1900 and 2000 euros. Question 13. How many people spent less than 1600 euros included? So we can just to clarify one thing in our mind, we can first of all have a look down this column and make sure that the actual value of 1600, sorry, doesn't appear. We can see by looking down that there's nothing which is exactly 1600, so we know there's nothing on the line. Now, to find out how many people spent 1600 or less, we know that the class up to 1600, so 1500 to 1600, this includes results all the way up to 1600. So if we look at the cumulative frequency, we know that this many people have spent up to 1600. Now this is actually the same as what the question is asking. It's asking us how many people spent less than 1600, which is the same as saying how many people spent up to 1600. So therefore we can say that the answer is 11 people spent 1600 or less. In terms of percentages, how many people spent 1600 euros, spent less than 1600 euros? So again, it's the same as before. We have the same answer, but we need to divide it by the total, which is the same as the column next to it, the relative cumulative frequency. So we can say that it's 36.67% that spent less than 1600. Question number 15, sorry. How many people spent more than 2000 euros excluded? So again, what we want to do is we want to have a look at this number. As this tells us how many people spent up to 2000 euros, and it was 24. So either we can take 30, which is the total, minus 24 to find out the difference of people that didn't spend under 2000, i.e. the number of people that spent more than 2000. Or what we've done here is we've taken the absolute frequency and all the absolute frequencies that appear after this interval of 1900 to 2000, so i.e. 2000 to 2100, 2100 to 2200, and 2200 plus, are all the people that spent over 2000. So we can sum up these absolute frequencies, and we get the same as what we would have got from the previous calculation, which is 6. So question 15, 6 people spent more than 2000 euros. Question number 16, in terms of percentages, how many people spent more than 2000 euros? So it's the same as before, but it's going to ask us in percentage terms. So we can see, again, we know that it was 6 people, so again, if we just divide that by the total, we can get in our percentage terms, or as before, we can add up these 3 columns, as it's, again, still the people that spent over 2000. So 10% plus 10% plus 0%, well, that equals 20%. So we can say to question 16, 20% spent more than 2000 euros. Then we have question 17. How much is the average spending based on the frequency table? So to calculate the average, also known as the mean, we need to first of all find the midpoint for each class. And so if we look at this table that I created below, we have each class as we did before. We have their frequencies as we did before in this column. But we need to put in a midpoint column. And this is essentially the average for each class. So the middle value between 1100 and 1200 is 1150. As we can see, that goes down, and it's the same, 1,800, 1,900, the middle value is 1,850. Then what we need to do to calculate we kind of calculate a weighted average. So we do the frequency times the midpoint, and that's what we have in this final column. So we have 1,150, as that's 1 times 1,150, and we do that for each class. And we have, then at the total, we have 50,600. Now that's our total, so that's each of our 30 results with their midpoint values taken into account. But now we need to divide that by 30, as we want to find the average value, not just the total value. So this, you can see the formula for this. The average is this column here, or this box here, the total for the frequency times the midpoint values, divided by the total frequency. And that gives us 1,686.67 euros. So we now know the average, or the mean, for the frequency table. Question 18 asks us which of the modal class and the medium classes of the frequency table. Explain how you calculated them. Okay. So in order to find out the medium class, first the median position must be calculated. In order to find the median position, we need to add 1 to the total count and divide it by 2. So this means that the total count is 30, we add 1 to it, it's 31, and we divide that by 2, we get 15.5. So now we know that our median position must be the 15.5th data point. The cumulative frequency column in the frequency table tells us that the data points number 12 to 17 are in the class of 16 to 1700, so we can therefore determine that 16 to 1700 is the median class. Okay, so what this means is, if we scroll back up to the table, we have, so we're looking for position number 15.5. We can see here that up to the 1500 to 1600 people range, there's already 11 people that are included. Either basically they spent 16,000 or less. And now when we go up to the next class, to 16,000 to 1,700, so 1,600 to 1,700, we can see that it's 17. So we know therefore that the 15 has to lie in between there. However, as the bin range is 1,600, the extra 6 people, so from 12 to 17, the 12th person and to the 17th person, must be included in this range here, which is the 1600 to 1700 range, which is why we were able to deduce that the median class is 1600 to 1700. This is also supported by the fact that actually if we look in terms of percentages, we know that the medium or the middle position must be the 50% mark, because that would make sense. And we can see here that actually from 36.67 up to 56.67 is in the 1600 to 1700 class. So therefore we know that the 50% or 50% person must be in this range as well, which again supports what we said before, the 1600 to 1700 range. The mode, which is the number that appears the most often, or the highest observation, is also the one with the highest frequency, as the frequency refers to the number of times the value is observed. So we look back at our table, and we just have to look at which class has the highest absolute frequency. And we can see in this column that the highest number is 6, which again is the 1600 to 1700 class. So with an absolute frequency of 6, the modal class is also 1600 to 1700. Question number 19, and the last question. Compare and explain why they differ from the central tendency measures in the raw data. So we now need to compare the values that we've just figured out, which is the mean value, the median class, and the modal class, with the raw data. So if we click back to our previous tab where we have the descriptive statistics for the raw data, we can see the mean, median, and mode. So what we did was we copied the mean, median, and mode into our little table that we created here. So we have the mean, the median or median class, and the mode and the modal class. Then we have the raw data and the frequency table data. Now for the mean, we can see that there's a difference of 9.23 between the two mean values. basically, there is difference. Well, what we want to have a look at is why these are different. The raw data is a more accurate value, as this has been taken from, or each data point has its own exact value. So this is where we abstracted the mean from. Each data point is accurate to its own value. Whereas when we look at the frequency table, this is how we calculated our mean. We take a frequency and we make an average of its class. So this is what the midpoint is. This is the average of the class, and it's also the midpoint number. And that's how we calculate that. That's why there's a slight discrepancy in the value for the mean from the raw data and the frequency table. This means that there's less certainty as the data points are given different untrue values in the frequency table, whereas in the raw data, the mean is calculated using a real value. To obtain a more accurate result, you can reduce the range of each class. For example, from 100, which they are now, we have gaps of 100. If we made it 50, then we'd obviously have a slightly more accurate. And as you make those classes smaller, if we were to make it 25 or 10, then we'd have more accurate, because the midpoint would be closer to the true value. So for example, if this was 1125, then the next one was 1150, the next one was 1175, and we had different frequencies, then we would be able to get a more accurate value for the mean. And in fact, when I say more accurate, we would see that the frequency table mean would tend towards the raw data mean as the classes become smaller and more accurate. For the median and the mode, we have different types of results to compare, as we have the median of the raw data versus the median class, and the same for the mode versus the modal class. Here again, the accuracy is determined by the precision of each data point. So here we can say, whilst both are correct for the median, 116 is correct, and 1600 to 1700 is also correct, as is proven by the fact that 111664 lies within that class. However, it's a question of accuracy. What's more accurate, 1664 or 1600 to 1700? There's more affinity to gesticulate in the range value, as it could be 1601 or it could be 1699. Whereas here we have one value which is by definition more accurate. The mode is more likely to be a better central tendency measure when the data has a normal dispersion, which makes sense, as the median, as the most often value, is more likely to be near the middle when there's a normal distribution. However, when there is not a large enough sample or not enough data, there will not be a mode, as no value is repeated. And that's exactly what's happened in this example for the raw data. In the raw data, we can see that each value only appears once, and therefore there is no mode. If we had, say, two 1634s, which we can see here, if we had, say, another one in the data set, then that would be the mode, and it would be our measure of central tendency. However, as we don't have that, or as we don't have repetition of any values, we have a NA produced for the raw data mode. For the frequency table, we can at least deduct a modal class, as it's the class that has the highest frequency. As we determined before, that was 1600 to 1700, because it has the absolute frequency of 6, which is the highest frequency. So thank you very much for listening. I hope you've enjoyed the little description, and I look forward to taking any questions. Thank you, class.